Okay, so this is already 56. The second one, negative 7 divided by negative 0.1 to the third power, that's 7,000. Okay, now, so the prediction I was making was that we would do this and we get very big positive numbers. But it's turning out the smaller number I divide by, the bigger answer I get. Last one, negative 7, as if we need another one, I'll go ahead and do it. Divide by negative 0.01 to the third power, and that turns out to be, so 7 million, all right? Definitely a very big positive number, okay? So that third power, when we take these small numbers and take them to the third power, they get even smaller. And then so when we divide, that division turns out to be even bigger. So maybe even more obviously than those first two examples, we're seeing it's going to infinity. All right, the smaller the x is, definitely the bigger and bigger the y is. Okay, now you could see it with either method though. That's my claim. All right, so the table is always there. I'll just do this next one with this method, because if I can get you on board with this, if I can get you to see this, then it's probably faster, all right, so long as this is something you're comfortable with. So if I did this one, okay, 7 over x to the third power, that's going to be 7, which is a positive number. And again, these are going to be like 0.1s and 0.01s taken to the third power are very small positive numbers, okay? All right, so what's 7 divided by a very small positive number? It will be, as we have seen in some calculations, it'll be a very big positive number, okay? So this one will also be infinity. All right. Now let's see, like, deviate even further from here and do something like this one. Now, my claim is that even though this looks more different and less like this first one, the same concept is happening. The smaller number you divide by, the bigger answer you get. That's my principle involved in all these problems that we're dealing with right now. So I'll show you my two methods. I'll make the table, and I'll show you just intuitively what we're going to get. All right. So here's my first method. The fastest one, so long as it's something that you feel comfortable with. If x goes to 3 from the right, that's going to look like 3.1 or 3.01. What's 3 minus 3.1? That's a small negative number. What's 3 minus 3.01? That's also a small negative number. Okay? All right, so here's what I'm saying. The form that this limit will take, if we make a table, is to be negative 4 over what will be a very small negative number. Okay? So I can see that. And maybe you can too. If you're not quite here yet, if you're not quite comfortable with that, I'll make the table in just a second. But for now, that's my claim. And if I take a negative, divide by a negative, I'll get a positive, but 4 divided by a very small number will be a very big number. Okay? So I'll get a very big positive number, right? That I'm claiming is suggesting this limit to be infinity. Okay. All right, now I want to complement this with something, and that will be with this second method that we should be very used to by now, or just to make a table. Hopefully if I make the table, it will make everything I was saying would happen right here. It'll make it more obvious. All right, but let's see. Seeing is believing, so you will get to see the numbers. Okay, so let's see. We got x. I need the x to go to 3 from the right. I'm going to get y. Okay, I'm going to see a pattern as x does one thing, y does another. Here's what x goes to 3 from the right. What's to the right of 3? I don't know, like maybe like 3.1. And then to get a little closer to 3, 3.01. And maybe to get a little closer, 3.001. Okay? So that's what x goes to 3 from the right could look like. Like with other tables I've made, we can argue about the numbers and why not 3.2 and why not 3.06, but the point is that they're getting in progression closer and closer to 3 from the right-hand side. Okay? All right. So let's do the math here. So I got my calculator off screen. I'm going to do -4, right, and I'm going to divide by 3 minus 3.1. And I know what that's going to be, but just I'll do the calculations like you would, and I'll get 40. You would get 40. I get 40. Okay, let's do the next one. -4 divided by 3 minus 3.01. That's going to be 400. So now we're seeing that's what we thought would happen. What's going to happen is you'll get -4 and you'll divide it by a very small negative number. You'll get a very big positive number. But the closer that is to 3, the smaller number you end up dividing by down there and the bigger answer you end up getting. So last one, this will be 4,000. All right? But you do the calculations and you get your numbers and you see the pattern here. The closer this is to 3, the larger that is. How large? No ceiling to how large. Goes to infinity. Okay? All right. Now, the table versus this quick method say the same thing. This quick method is just my way of seeing that that's the way the table will work out. Now, you do what you're comfortable with. If you like the table because you're more comfortable seeing the numbers, then that's okay. But if you can grasp this, it's a lot faster to do it that way. Okay, I'll leave it up to you. So what about this one? So limit x goes to 3 from the left. Okay, so two sides of it. My first method, I think, here's the way that's going to look. You're going to get -4 over. What's 3 to the left? Going to, what kind of numbers are we going to be dealing with? 2.9, 2.99, something like that. And what's 3 minus 2.9? It's a very small positive number. What's 3 minus 2.99? It's also a very small positive number. Okay, that's what those are. So okay, that's what you're going to get. Now, so I'll say down here, the way that the calculations are going to look is -4 over a very small positive number. Okay, -4 over a very small positive number. Well, so a negative divided by negative is negative. But when you take something and you divide it by a small number, you get a big answer. That's the way division works. That's what I was trying to establish here. When you take 1 and you divide it by a small number, you get a big answer, right? It's just a basic truth of arithmetic, I guess you could say. So I'll get here a very large negative number. Oh, this limit's going to be negative infinity. I can tell that's the way that the table is going to work out. All right, but like I said, it doesn't matter to me how you do it. I'd like to get you to understand this. And if it means that I need to make the table to make that happen, then I will go ahead and do that. All right. So I'll make the table really just to provide a complement to this. I'll give you a way to believe that, understand it. Okay, so I got x, I got y, calculated like this. X goes to 3 from the left, okay? That might look like 2.8, 2.9, 2.99. That's definitely going to 3 from the left-hand side. That little negative sign right there, that doesn't mean negative. It means from the left. All right. closer and closer and closer to 3 from the left-hand side. On the number line, all of these numbers are to the left of 3. That's what we mean by that. All right. So let's do our math and see what we get. So we get -4. We divide by 3 minus 2.8. And that turns out to be 5. We get -4. Divide by 3 minus 2.9. That turns out to be -40. Sorry, I forgot to write the negatives. -5. Okay, and then -4 divided by 3 minus 2.99. And that turns out to be -400. Wait a second. I must have hit a wrong button or something. That should be -20. Okay, so excuse that. -20, -40, -400. So yes, very large negative numbers. All that's happening here is I'm getting a very small positive number down there, and I'm dividing it into 4, and I'm getting a very big negative number. Okay, so we're going to negative infinity. Larger and larger and larger negative numbers. That's what we see in the table. X goes to here, y goes to there. Okay, final answer to that limit, negative infinity. Okay, now I really would like you to see the table is really being the same thing as that. It's not different. Okay, this is just a way somebody could understand how the table would work out without having to go through all the details. Remember, I did say it doesn't matter to me how you actually do it. Okay, I'll just show you the different ways you can think about it, and you have to find one that you're comfortable with. All right. Okay, let's look at maybe 2 more that I think will cover this topic. So what about this one? Okay, again, I want to do by table and by graph. All right. If I take this and x goes to 5 from the left, here's what I think is going to happen. Okay? Or how about this? Let's do one more thing that I think might help us out. Limit x goes to 5 from the left, and it might help me to see this as x plus 5, x minus 5, okay? So I might look at it like that. So here's what I think is going to happen. If x goes to 5 from the left, this will essentially be 6. 5 plus 1. Or, okay, 4.99 plus 1. All right, it's basically going to be 6. So I'm going to get like up there. It's going to be about 6. Close enough to 6 for me to just call it 6. But what about down here? That number right there is going to be 10. But what about this one? This one's the one I'm really concerned about. So x goes to 5 from the left. So we're saying like 4.9, 4.99. What's 4.99 minus 5? It's a very small negative number. Okay. It's a very small negative number. Now, I'm saying that all things considered, this is going to be a 6 over. What's 10 times a small negative number? It's also going to be a small negative number. All right, I'll try to get you to have the instinct for that. But say I take 10 and I multiply it by a small negative number. My claim is that what you get is going to be very small and it's going to be negative. So what's a small negative number? I don't know, like that. Can we be happy with that? Small negative number. Okay. Oh, so you get a small negative number. Okay, you multiply something by a small enough number closer to 0, it's going to be small also, but it will be negative in this case. So I'm going to get a very small negative number as my like grand total down there. And so what's 6 divided by negative? It will be negative. But what did we say so far happens when you take something and you divide it by something small? You get something big. So this will be a very big negative number. Okay, it's going to be negative just because of the signs, but taking 6 and divide by something small is going to get you something big. Okay, all right, so my limit will be negative infinity. All right, so I'm comfortable making that conclusion by thinking about it this way. All right, now maybe this is all I need to do just because like I have the right instinct about numbers, like I've done a lot of math, I've seen how it works out, I've looked at lots of tables like for a long time, but all I want to do is either that you see this now or maybe me try to encourage you to get to that point. So how about this? Let's make our table just to be on the safe side. Just to give you some proof or some tangible way to see what I was talking about over there. Okay? So, okay, here goes. We're going to do x, and I'll just plug into that first one. I could use this one if I wanted to. It doesn't matter. I just wanted to show you what the numbers were. Okay. So I'm going to 5 from the left. All right. So that might look like 4.8, 4.9, 4.99. This or something a lot like that is x going to 5 from the left. Okay, so let's see what we get. All right, so 4.8 divided by 4.8 squared minus 25. First number turns out to be about negative 2.45 with some rounding. That's roughly what you get. Okay. Oh, I'm sorry. I made another mistake. How about this? I'm just going to pause this and make the table and unpause it. Hold on. Okay, so I did all the calculations. I actually decided once I had gotten down to that one, I thought maybe this isn't quite dramatic enough that the y is going to go to negative infinity. So I might be the case when you make a table sometimes. I decided to push a little closer to 5. Okay. All right. So I added another number and I did the math, and now I'm a little more happy with it that it supports that. But you know, how close to 5 can you get? I mean, there's really no end to it. I can always put another 9. So if I wasn't comfortable with the pattern I was seeing, if I wasn't convinced of it, I can always go a little closer. So that's what I decided to do here. And look what happened. We got negative 2.9, then to negative 5.9, then to negative 59, then to negative 599. Keep going. The closer you push this to 5 from the left, the bigger that's going to be, the bigger negative number you're going to get over there. So it's going to go to negative infinity. Okay? As suggested over here, but seen maybe more tangibly with the table. All right. Now, so even up to this one, given that it did look quite a bit different than the very first one I showed you, it's the same concept, right? I mean, it's so much in math. We learn some like basic idea. All right, we get comfortable with it. We understand the basic idea. And then we try to see it in other scenarios that look different. We try to see that the same thing is really happening. All right? So like maybe on first glance of this lesson, I'd like you to see that, well, this one we started with, this very first problem, really in the end the same thing was happening with it. The same principles going on as this one, which, you know, initially looked much different. But we can learn to see, hey, it's the same concept. That would be the idea.